Hello everyone, my name is Ibrahim, my surname Mamajanek, my student number is 20202549. Okay, today I'm gonna make presentation about elementary functions. Okay, let's start. First of all, we should know about the type of the elementary functions. The first is constant functions. The mathematical, the constant functions is the functions whose the value is the same for every input value. For example, the function is, let's draw. The function is y bracket in x equal 4. Y bracket in x equal 4 is a constant function because the value of the y bracket in x is the 4 targetless of the input value x. Okay, the next, the exponential function. The exponential function is a mathematical the relation of the form y equal ax with independent variable x ranging over the entire real number of lines as the exponent of the positive number a. Okay, the next is a logarithm. For example, let's write here. For example, two. No. 2. Equal 22. The exponential function is the 22 read as a 2 raised by the expanded of 5, or 2 raised to the power 5, or 2 raised to 50th power. Then the logarithm function is given by f, and logarithm is given by f bracket in equal logarithm bracket in logarithm b x equal to y, where the b the basis, y is the exponent, and x is the argument. Okay, I am sorry, I am drawing a bit the ugly because I am using by mouse for drawing this kind of formulas. I am sorry for that. Okay, is the next thing the trigonometric function. The trigonometric function is a really important function for learning for us, for students, because the first thing we should learn about the trigonometric functions special words. For example, let's see then. We always use this kind of things, but most students may not know about this, the words of the special words of the trigonometric functions. For example, Sine, we always use like that. Sine is cosine. We use it to write small things like bracketing, cosine, okay. This word is really important for trigonometric functions. We always use from them for using trigonometric functions during using the trigonometric functions. So we have to learn, we have to know about them fully, and anytime, anywhere we use these spatial words of the trigonometric functions. Okay, less than function is which should we learn hyperbola functions. In the mathematical, hyperbolic functions are analysis of the ordinary trigonometric functions, but defined it using the hyperbola rather than the circle. Just a point. Okay, let's draw. I think the draw is better than just talking. Okay, just a point. Cosinus t and sinus t forms the circle with a unit radius. The point is like that. The point is like that. The point is like that. Sorry for drawing like ugly. And just I want to share my idea fully with through drawing. Okay, I think that's enough for explains the functions, but during the another parts we will learn about them more. Okay, let's move. Okay, what's elementary functions in the calculus? Just a mind, clean. Okay. What's elementary functions in the calculus? The concept of calculus created modern science and revolution the world. The calculus is a fundamental to modern science and it turn is founded on a solid understanding of elementary functions. Okay, elementary functions are the functions which occur in the most of the calculus in the basic math explanation. They include the polynomial functions, rational functions, trigonometric functions, exponential functions, and their inverse functions include the inverse trig functions and the logarithms, along with the functions created by the composing as a squares of the elementary functions. Almost every function appearing in the scientific or economic applications is elementary functions. In this course, we will focus on the understanding these functions and the successfully manipulating them with the appropriate algebra techniques. In the preparation for success, train into the calculus. Okay, back to the constant functions. As we will learn in this part, we will learn about constant functions more before the first part. Okay, constant functions, the functions having the same range of different values of the domain. The graphical is a constant function, is a straight line which parallel to the x-axis. The domain of the function is the x value, and is responded on the x-axis, and the range of the function is y, or fx bracket x, which is marked with a reference to the y-axis. This example is, as I mentioned, the first part is y. Okay, y bracket x is a constant function because the value of the y bracket x is the targetless of the input value x. You can see here in the line. Okay, let's move another part. And we will learn about more about exponential functions. Okay, in the mathematical exponential functions, the function of the form f bracket x equal to a power x, where the x is the variable and the a is the consist which the call is the base of the function of it should be greater than 0. And here you can see the forms of the exponential functions. For example, f bracket x equal to b power x, or f bracket x equal to ab power x. And these things, these forms, and which we can learn, we can use this kind of from these forms during the practice or during the our practice time. Okay, here you can see b greater than 0, but b not equal to 1. It's the exponential function. Part we will learn about the logarithm more. Logarithms is another way to writing exponents. We know that 2 power 5 equal to 32, but if you are asked to find the number of replace the question mark in the in 2 equals 32, then by the trial and error, we can simply find the answer is a 5. But if they are asked to find the question mark in the 2 power question mark equals 30 question mark, is there are any numbers such as 2 raised to give 30, not then how to solve it. The solution is a logarithm. Let's to us learn more about logarithm along with the rules, preparations with example. Let's move the examples and practice part.
Okay, let's move to the next. So next, I'm going to show everything in the graph. So here I found a good platform where I can draw all the graphs. So first, let's see the graph of the constant functions. Constant functions are one of the elementary functions that occur many times. So for example, y is equal to the constant value. For example, the constant values may be rational numbers, maybe p, maybe exponent, and etc. And the constant values are the values in which we don't have any x. So for example, y is equal to 2. 2 is constant value. 2 is not changeable. So the graph would look like this. The graph would be parallel to the OX line. So, or else we can draw, for example, 4, 5, or just we can write here P. Yeah. As you know, the value of the P is equal to 3.14, and the line is parallel and crossing the OY in the 3.14 point. So next, or else we may write here E exponent 2.771, and it's parallel to the OX. This is the graph of the constant function. That's all. And next is going to be, for example, constant functions are not all the time in this way. For example, they may be written in this way too. X is equal to 1. This is also constant function because the value here of the function is not changeable. Next, so then we're going to move to rational powers of x. Yeah, rational powers of x. So they would look like this. Y is equal to x in power, for example, 1. It would look like this, or 2, 3, 4, 5, 6. Yeah, you will have all the powers, any power, rational power. It may be even fractions like 2 over 3. This is also rational power of x functions. Yes, you will have x, and in the power you will have any type of rational number. And draw will be different according to the power. For example, if we have even numbers in the power, so the graph would look like this: 2, 4, so right, 4, 6, or 8. Yeah, the graph would expand a little. But if we write odd numbers, for example, 1, 3, 5, 7, 9, the graph would look like this. Yeah, the graph would situate in the first and then the first parts of the coordinate. So next is going to be exponential functions. Yeah, exponential functions are the functions which are opposite to rational powers of x, because here we will have x not in the base but in the power, in the exponent part. That is why these types of functions are called exponent functions. So in the here I will have, for example, 4 or 34, any number, and in the power we will have x. Yeah, so for example, x, the graph would look like this here, the green line. Or in the base, let's write 4, the graph would look like this: 6, 7, 8, 9, etc. So for example, 5. Yeah, let's move to the next. So here it is going to be, next one is going to be Logarithms, yeah, logarithms. So logarithms are the ideas. So logarithm is the idea which came from, this is also elementary function, and in the logarithms we will have in the base any number, and in here a little bigger one would be x, and x would input so any values, then we can draw the graph. So do not wonder what is ln. Ln is just logarithm is the base of 10, that's all. So let's see how they would look like in the graph. So for example, y is equal to logarithm logarithm. So here I had a calculator. Functions, logarithm. Okay. Oh gosh. Stop. Logarithm. It must be here. Yeah, logarithm is here. So in the logarithm here we will write any number, and here we need to write x, and the graph would look like this. Yes, as you see, for example, let's write in the base, for example, 5. Yeah, you see these green lines and purple lines are very similar to each other, because the idea behind powers and this type of exponent functions are very similar. Next is going to be trigonometric functions. What are trigonometric functions? Trigonometric functions, for example, we have sinus and cosinus. Y is equal to sinus of x would look like this, and we have cosinus. Let's write it in a different one, is equal to cosinus x would look like this. Yeah, the graph would continuously go to the point to the from the minus infinity to the plus infinity. Yeah, and then the maximum value for y would be 1 and means minus 1. Tangents and cotangents will come from sinus and cosinus. As you know, tangents is equal to sinus over cosinus. So for example, my is equal to tangents of x would look this. The graph would look like this. It goes from minus infinity to plus infinity. So next is going to be cotangent. So y is equal to cotangent of x. The graph would look like this. So here is the interesting point. So these are the elementary functions. All of them are elementary functions. So this is the end of my presentation. So today we learned the types of elementary functions and Euler's function. So I hope you enjoyed the video. So I'll try to do my best to make more videos and learn elementary functions in detail. So thanks for your attention. Have a nice day.